Love is a very interesting phenomena. Scientifically, its origins were the result of a necessary series of chemical reactions geared toward the survival instinct for reproduction, combining with the complex neurocircuitry of the brain and, by extension, consciousness. What is love has been a question studied and debated by scientists, philosophers, and an innumerable number of scholars throughout history. However, perhaps that's the problem with regards to thinking about it. Academia represents our fundamental need to understand what we don't know via the action of classification. And by the definition I just gave, these C. elegans, often used to examine behavioral patterns in humans, love when they select a mate by how many chemicals they secrete. The love that we humans share takes on so many different forms and so many different roles that it's arguably not worth classifying, much less understanding. Our love is so succinct from so many things in the natural world that it may as well be considered unnatural, and yet it feels so natural to the human experience. I don't know about you, but I personally believe in the existence of a God, and I believe that the unexplained explainables like love are perhaps the greatest proof of that existence. And if that supreme being I worship is real, then conversely, I truly believe that it's amazing that he chose to give us the unique ability to love. Yeah, so I made an equation.
वाह क्या लड़का है, वेरी हैंडसम बॉय, इससे तो बहुत मजा आएगा।
Prom is coming up for most high schools in the United States, including mine. And if there's one thing I've learned about prom from the people in my high school, it's that all of you are desperate. At least enough of you that I can make this video, but frankly that doesn't sound as enticing, so we're just gonna go with all of you. Anyway, I've seen half of you asking out as friends, alright, and still getting rejected and put in the friend zone. Alright, I've seen people pull a 007, alright, 0 Riz, 0 pulls, and 7 months since you last said, I'm going to ask her out. And finally, I saw someone, I kid you not, in chemistry class on rentapromdate.com. I can't even find the website anymore. I'm assuming it got taken down considering the 20-year-olds that were on it. That's not renting a prom date. That's renting a restraining order. Notice how I said people, alright? Not persons. Except for the last one, bro. That was wild. No reactions in class and no action in the hallways is a crazy combination. Anyway, needless to say, all of you need help. And that's where I come in. As the certified president of Mu Nation, with a jawline that most people can only dream of, I've decided to grace your desperate ears with my wisdom. As Isaac Newton developed mathematics to discover the laws of classical physics, so too shall I use mathematics to determine the laws of modern Rizzimatics. If you ask someone out, there are 2 things they can realistically say. Yes or no. Now, as you might have guessed, this is actually a question of probability. So to help us visualize this whole scenario, let's construct a tree. We're going to label each generation or iteration of the tree from 1 through 4, and these are going to be representatives of the number of people you ask out. And it will be split into 2 parts. Yes, I want to go with you, and no, I don't want to go with you. Now, if you get a yes, then there's no need to continue the tree. But if you get a no, then the ideal thing for you to do would be to keep asking until you eventually get a yes. Now, there's some fixed probability for getting a no and some fixed probability for getting a yes. Let's label this fixed probability yes and no with the letters y and n. We can conclude that the total probability for y plus n must equal 1 by basic probability rules. Now here, I'm honestly doing some basic labeling for my sanity, but the next part is actually pretty mathematically important. We're going to label the total number of people who asked P. Now because each person who asked is an independent event, unless you were so bad at rizzing that the news somehow spread to literally everyone you asked, assuming the probability of being rejected is constant for each person you asked, then the probability of getting rejected is n to the power P, where n is the fixed probability of getting rejected for one person, and p is the number of people you ask. Now, to get the probability of you getting accepted, all you have to do is remember the n plus p equals 1 rule, and consider the expression 1 minus n to the p. where n is a number between 0 and 1. Here you can see the graph that arises from these distributions, where blue represents the probability of someone saying yes, and red represents the probability of someone saying no. Focus on the positive x-axis of the graph, since you can't ask negative people, and as you can see, the probability shifts more positively in favor of saying yes as your individual Riz as a percentage goes up. So now we have two base probability distributions that make sense with regards to modeling the situation. In the sense that it tells us mathematically that if you talk to more people, you're more likely to get a date. It also tells us mathematically that if you talk to nobody, then you have a 0% chance of anybody taking you out on a date. Which I originally thought seemed obvious, but I know people who could use that advice. And we're going to codify this mathematical principle into the law shown on screen. Although this law is good, it's not as definitive as I would want it to be. Why? Well, in order for the law to work, you have to know your n beforehand. In other words, you have to know the likelihood that the person you're asking out will reject you. Unfortunately, for specific individuals, I can't really tell that for you. Look, for individuals, there's so many different factors, from hobbies to interests to looks to how good you smell, that help determine whether you get accepted and go with, I don't know, the love of your life, or you get ghosted in person. Anyway, maybe my inability to calculate individual thoughts is proof that love is truly an incalculable endeavor. Maybe it's proof that love is not meant to be predicted, only experienced. But if I'm being frank, that answer isn't going to get me views, and it's not going to get you a date either, so let's move on. If we can't work with individuals, then perhaps we can work with the general trend. Generally, subjective qualities like attractiveness follow something that we like to call the bell curve phenomena, where essentially most people are considered average, a few people are considered super hot, and a few people are considered super unattractive. Kind of like, as its namesake suggests, a bell curve. Now with attractiveness, there is one big exception to this trend, but we're going to account for this later, trust me. For now, let's assume that most people follow this normal Gaussian.
You are my sunshine, my only sunshine.
We're going to rate everybody on a scale from 1 to 10. 1 obviously being the worst, and 10 obviously being the best in terms of attractiveness, and 5 serving as our average, aka our mid. As we're going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 is going to be our standard deviation, aka average distance from the mean. Luckily, the normal distribution is a function that has been studied quite extensively, and there is actually a formula for it shown on screen. All we have to do is just plug in our suggested values into this formula, and it simplifies to this expression. Okay, so we now have the formula determining the population distribution for attractiveness. But how are we going to connect that to the probability that someone will say yes or no to you? Well, here we're going to have to make some mathematical assumptions. Let's say you're a 6 and you decide to ask out a 4. Are they going to say yes? The answer is yeah, probably. Now, conversely, let's say you're a 4 and decide to ask out a 6. Are they going to say yes? The answer is no, probably not. Unless you have some god-tier Riz, but if I'm being frank with you, you're watching this video, so you definitely don't. Otherwise, you wouldn't have your ex from middle school being added to the GC. Casual roasting aside, unlike that middle school fling, this gives us a nice relationship to work with. Or in other words, something that can be represented as the area under the bell curve that we were talking about earlier. This means that the probability someone will say no to you is equivalent to the part that is not shaded here, or more mathematically, the area of the whole function minus the area of the highlighted portion. Because the function is a probability density function, the area under the whole function is just 1. Whilst according to the fundamental theorem of calculus, integral expression can be simplified to the one shown. Since we have our distribution function, all we have to do is plug it in and bam, we have an integral to solve. Now from here, there are two things we can do. The first is plugging the integral into a computer program and having that do it for me. Cheating, essentially, just like some of you with your relationships. Or I could actually commit and, do the integral on paper. all we have to do is plug in this equation into our n formula and Desmos, and we'll have our graph answer. And here's the equation. Looks complicated, I know, but remember, all we have to focus on is where the graphs meet. And that's here. Now, what is this number telling us? Basically, if you were to go around with all your friends and ask randomly, would you accept me as a prom date? The odds of someone saying yes to you would be over 50% after the 5th person. In other words, if you're really desperate, just ask around randomly, and by around the 6th or 7th time, you should get someone. And this graph works perfectly for women. Remember when I said earlier that there was going to be one big exception to this? The big exception is actually gender. Many studies have actually already been done on how people rate each other's attractiveness. And it's true that men rate women's attractiveness on a normal distribution curve with a mean of 5. Hence why the curve I just showed works for women. However, women are actually stricter when it comes to rating men's attractiveness. They also follow a normal distribution curve, but it's shifted approximately 3 units to the left. Essentially, a man calling you a 5 is the equivalent to a woman calling you a 2. Essentially, to get an equivalent curve for men, we have to shift it 3 units to the right. So instead of getting better than 50% odds on the 6th person you ask, you're going to get better than 50% odds on the 9th person you ask. In the video's description, there are 2 links below. The first is the Desmos link to the first graph. Use that one to figure out your individual probability, especially if you're trying to, go for someone. The second link will lead to the graph I showed just now, and that one, as I showed you before, is based on complete randomness and trends. Use that one if you actually have nobody and are just desperate. I'll mark the one for women and I'll mark the one for men. And with that, so far, the longest Shobit Mukherjee video is complete. And now you truly, mathematically have no excuse to not get bit.